Hello, I welcome you all to this interesting screencast. We're going to be solving this engineering mechanics problem, and it reads draw the free body diagram of the bar, which has a negligible thickness and smooth points of contact at A, B, and C. Explain the significance of each force on the diagram. Right. This problem is coming from the engineering mechanics statics textbook by R.C. Benam. Right. So we have this bar, okay, and there is a force being exerted by this human hand, and for this bar to be in static equilibrium, we are going to expect some reaction forces and some normal reaction forces at the contact A, B, and C. And since these contact points are smooth, it means there's not going to be any friction, or friction is going to be neglected. Right. So let's draw the free body diagram. At A, look at what is happening. The bar is being pushed, okay, it's being pushed in this direction, right? So if the bar is being pushed in this direction, of course there is another component in this direction, right? Okay. So we have two components from this. We have one component in this direction like this. We have another component in this direction like this, right? We have two components. Okay, so let's draw our axis. So we're going to assume this is our positive y-axis, and this is our positive x-axis. Okay, so this is our assumed axis. So we are saying we have these two forces, and this force here is going to be equal to 10 cos 30, right? And then this one is going to be equal to 10 sine 30, right? Okay, let me write this properly. All right, so this is 10 cos 30. All right, and so there is this force 10 cos 30 exerting a force in this direction. So what do we expect? We expect a reaction force here, and it's going to be in this direction like this. So let's call this A, normal force A, right? And as the force is pushing this bar in this direction, okay, this bar will tend to, because it will tend to rotate like this, right? So this force at this point makes the bar to rotate in this direction about point A, right? Agree? Okay, to rotate in a anti-clockwise or counterclockwise direction. But this rotation will be restricted by the contact at B. Okay, and therefore, because of this restriction, we expect to have a reaction force also at that point, right? And this reaction force is also going to be normal to the bar like that, right? And we call it normal force B. Okay, and if we took B as our reference point of rotation, or even the same A, right? So we have a force here and the same reference point A, okay, as our point of rotation. This part tends to rotate like this, but it will fail to rotate because it is being restricted by B, okay, and also it is being restricted by C, right? Right. So we expect to have another reaction force, normal. This time around it will be normal, it will be in this direction like this. Okay, let me draw this, of course, there. So it will be in this direction, right? Because look at the direction of the point of contact. Right, let me redraw it properly. Okay, so we expect a normal force here like that. This one will just come, it will be straight like this. Okay, this one here is a 90 degrees, right? Alright, so we'll call this one as normal force C. Alright, so this is 10 sine 30, which is a 5, right? Okay, I just want to remove it here so that we don't confuse it with this normal force because they are too close to each other. This one, it is this one here, this one here, this one is C. Alright, so we have all the forces. So we've just been asked to draw the free body diagram, but of course we'll go ahead to calculate these normal forces. So before we do the calculation, let's add missing information. We realize that we do not have the lever arm or the lever distance from B to this point. You've seen this point, we need this point if we are to take moments. Okay, we need to know what this length is, right? So this length, given this angle 30 here, we can say, we know that tan 30 is going to be equal to opposite, which is this length here. Let me call it y prime, okay, divided by adjacent, which is 3 inch. And therefore my y prime will be equal to 3 tan 30, right? Therefore this one is equal to 3 tan 30 degrees. Okay, alright, so can I wrap this? We have all the information that we need. So what we are going to do is we are going to apply the equations of equilibrium quickly to find what reaction force or normal force A, B, and C are. So I'll take moments about, let's say, about point C, and then apply the equation, the moments about point C, and then summation of forces in the Y and in the X, and then you solve for the unknowns. So I'll say summation of moments about point C, and clockwise being my reference positive. What do we have? About point C, we are going to have a positive B by 3 tan 30, right? What else? We have a clockwise of what do we have? We have a clockwise of minus A by what? By 5. And then I have another clockwise of 10 sine 30 is 5, but I'll write it like this: 10 sine 30 by 3. And then I have the anti-clockwise of 10 cos 30 by 8 plus 5, that is a 13, right? It's a 13. What else? I think basically that's about it, is equal to 0. So here we have two unknowns. We have A and B. Alright, can we simplify this one? We can. What is 3 tan 30? So we have here a 1.73 B minus 5A minus, this one is a 5 times 3, which is a 15, plus this is a 10 cos 30 times 13. This gives us a 1112.58, is equal to 0. Alright, so let's write this in terms of A therefore is going to be equal to, alright, let me just try and resolve this. Alright, just 12.8 minus 15. Okay, what do we have? We have that, and then divided by 5. So here we have a 19.52, okay, a 19.52 plus 1.73 divided by 5 plus a 0.346 B. So this is the expression for A. Yeah, I think I've not made any mistake. Okay, so that is the expression for A. In terms of B, right? In terms of B. So with that, we need now to find the other expressions. So say summation of forces in the x direction is equal to 0. Alright, So what we have, C, we can also resolve it into components. So C will have two components. This we have one component like this, but we know this angle here, this angle is going to be equal to 30, right? That angle is equal to 30. Okay, and then we're going to have another component in this direction. We're going to have another component in this direction. Oh, come on, I'm failing to draw this straight line. Something like this. Alright. Okay. Oh Lord. Okay. So something like this. So then this component is going to be equal to C cos 30. And this one it will be C sine 30. Great stuff. So we have all the components. So summation of forces in the X, we are going to have, we have C sine 30, right? Then minus A, right? Then plus 10 cos 30. What else? I think that's about it, right? And B, right? Plus B is equal to 0. Alright, this is about it. Then we have summation of forces in the Y. What we have in the Y direction, what we have in the Y. Okay, in the Y we have a minus 10 sine 30, which is a 5. What else? We have a plus C cos 30. What else? We have that one and that one. I think that's about it. We have this component in this direction and in this direction. That's about it, right? I think you don't have anything else. Is equal to 0. So this makes even the work easier. Therefore, my C is just going to be equal to, my C is equal to 10 sine 30 divided by cos 30. Is that so? So this gives me a 5.77. This one is pounds. Alright. So we found what C is. Let's replace C. Here we get this C, we replace it there. And then we replace this A here. Okay, let's do that. If we did so, then we are going to have the following. We're going to have 5.77 sine 30 minus, what is A? A, we said we are going to multiply in advance by a minus. We've seen this minus, so minus by 19.52 becomes minus 19.52, then minus by this number 0.346b, so it becomes minus 0.436 346B plus 10 cos 30 plus B is equal to 0. Alright, so here we go. Let's sum up everything. Let's sum up the B's. Let's sum up all the numbers we have and divide it by B. What do we have? Our B here is going to be equal to, so let me do the multiplication. 5.77 sine 30 minus 9.52 plus 10 cos 30. We have that number there, and then we subtract. So we have, let me write it. I think I can divide directly, and then we'll say this is a minus, so it's giving us a minus, and then we have, alright, this is just fine. So then divided by minus, or just 1 minus 0.346. What do we have? We have a 12.19 pounds. So we found everything, I think so. Right, so let me just extend this B so that it goes up to there. I write it here as B so that I include all the answers, and also I extend this one as my C up to here. This is my C. Alright, okay, so let me now write down all the answers in blue. My A is equal to, what is my A equal to? I didn't find my A, right? Quickly, let me find my A. Therefore, my A is going to be equal to 19.52 plus 0.346 times B, which is 4.19. So this one is equal to 23.74 pounds. Alright, so my A is equal to 23.74 pounds. My B is equal to 4.19 pounds. Alright, sorry about that. Okay. Alright, so there we go. So B is equal to 12.19 pounds. Okay, and my C is equal to 5.77 pounds. Alright, I guess we are done. So these were the reaction or normal forces at point A, B, and C. And not only did we draw the free body diagram, but we had to solve them. And I hope the video was helpful. And if it was, please give me a thumbs up, like my video, share my video, continue subscribing. Bye bye, and see you in my next screencast.